Hi, everyone, and welcome to the Introduction to Quest video series. My name is Saya Dennis, and I'll be walking you through the basics of Quest today. Here's the outline of this video series. In the first section, I will go over the basics of what Quest is and what you can do with it. In the second section, I'll give you an overview of how you can interact with Quest alongside the high-level views of the Quest infrastructure. In the third section, I'll walk you through how to navigate the file system using the command line. And in the fourth section, I'll explain how you can manage and use software on Quest. Finally, in the fifth section, I'll be walking you through the details of how to set up your job submission. So let's get right into the first section. What is Quest? Quest is Northwestern's high-performance compute cluster, or HPC. Now, this might sound like gibberish to some people, so I wanted to break this down for you. Quest is called high performance because the computers that are available at Quest are typically much more powerful than your personal device. So your laptop might have a few gigabytes of memory and perhaps 4 or 8 CPUs, but an average computer on Quest actually has hundreds of gigabytes of memory and dozens of CPUs available. So you can kind of get an idea of how much more powerful a single computer at Quest is in comparison to your personal device. The other part that I think might be confusing is the cluster part. Quest is called a cluster because it consists of hundreds of computers that can work in harmony with each other, that can communicate with each other. So this is why Quest is called a high-performance compute cluster. All right, here is a bird's eye view of Quest. As I mentioned, it consists of hundreds of nodes. Now, in this context, you can think of the term node as something interchangeable with the term computer. Let's take a closer look at one of these nodes. Each node on Quest has somewhere between 40 to 64 cores. Here, the term core means the same thing as CPU or processor, if you're more familiar with those terms. Now, let's focus our attention on this single node to see what it's doing. As you can see in this illustration, each node can be running a bunch of jobs at any given time. Here, you can think of the term job as a prepackaged sequence of commands that a user submits. Some cores are running Python, some are running R, and some are running MATLAB, as you can see. As you might know, some jobs can run on multiple cores simultaneously. These are called multi-core jobs. On this slide, I'm illustrating what this might look like with the dashed yellow line. You can see that there's one MATLAB job running on 2 cores and one Perl job using 3 cores. It's actually even possible to use up all the available cores on a single node. However, not all workflows parallelize effectively at this scale. If your job doesn't parallelize well across dozens of cores, perhaps, another way of scaling your workflow on Quest is to submit a lot of single core jobs. You can submit hundreds or even actually thousands of jobs at once on Quest. Finally, jobs can even run across multiple nodes on Quest. This is an extremely powerful use of an HPC, but be careful because there's no default behavior that allows this type of parallelization. Your workflow needs explicit programming to enable this behavior, so you will have to check what the software you're using to see if this works. And I'll talk a little more about this in a later section of this video. All right, so in this section, we focused on the high-level view of what Quest is and what you can do with it. In the following sections of this video series, I'll be walking you through a more detailed view of how Quest works, how you can navigate it, and how exactly to submit your jobs. Thanks for watching, and I will see you in the next video.